What's up guys, I'm Derek Craig here with Oil Field Basics, and today we're here at Marietta College's Oil and Gas Technical Exhibition, and I'm here with Des Murphy with Halliburton, and he's going to walk us through their new rotary steerable tool.
Hi guys, as you said, my name's Des Murphy. I'm the Area Technology Manager for Halliburton here in the Northeast area. I'm responsible for the deployment of technology across all our PSLs into the basins where we operate. And as you said, today we're looking at our new rotary steerable tool. It's called the iCruise. It is our next generation push the bit rotary steerable tool. Those of you who know about rotary steerables know we have push the bit and we also have point the bit. This is a push the bit system. We find a push the bit is much more applicable to building the type of curves we need to correctly and accurately land laterals in these unconventional formations where we operate in, to ensure that we get the maximum amount of lateral coverage, so we make sure we can extract as much as possible the amount of hydrocarbons in the ground. Very simply, starting from the top, we have our what we call a superflex. This is a superflex sub. This is a part of the tool that enables us to bend. So when we're building these high angle curves, we need to be able to bend the tool. Otherwise, obviously, the more stiffer assembly you have, the harder it is to build a large curve. So this superflex assembly quite simply allows us to get those high build rates that are required for some of these more complex well geometries that we see in the Marcellus and the Utica. So it's just a fairly simple piece of dumb iron, but very, very important to our operation. Down here is the most important part. This is the steering head. This is how we directionally change the direction of the well bore to make sure we're following the well path. Basically, very inside here we have a gamma ray sensor. This enables us to know where we are in the formation based on the background radiation of the formation, which is made up of thorium, potassium and uranium. What we have here, we have fluid flowing through the entire tool assembly. The fluid comes down here, through here, out the bit. Once it comes out the bit, it's there to keep the borehole clean by taking away all the cuttings, and also to keep the borehole temperature down. That fluid flow keeps the temperature down so we don't have to worry about high temperatures impacting our equipment. But at the same time the fluid is flowing through here, it is turning a generator which is providing power to the electronics inside the tool, and is also providing the hydraulic power necessary for these pads to open and close to force the bit in the direction that we want it to be. So the entire tool string is capable of rotating at 400 revolutions per minute, and each one of these pads will come out at almost 6 times per second to directionally push the tool where it needs to go. So that way, based on the directional plan and based on the controls from surface, we're able to steer the bit into the well path. Very, very accurate system. Push-to-bit rotary systems have been around for a long time. This is the latest generation of push-to-bit rotary steerable. Our customers have come to us and said, we want smarter tools, we want tools that are drill faster, and we want tools that are tougher. So one of the Halliburton strategic mainstays is listening and responding. So we've listened to our clients and we responded with the iCruise system. It's smarter. It has 6 microprocessors in here that take over 1,000 measurements a second based on inclination, azimuth, gamma ray, ROP, vibration. We're able to take all that information and store it and send some of the information up hole, so we're able to directionally steer the tool. It's tougher. Its construction inside is modular, so it doesn't have a lot of the complexity associated with most rotary steerable tools. That complexity can cause failures. The modular construction ensures that we're able to drill longer and harder with less downtime due to tool failures. And we are able to drill quicker. This tool will drill 400 RPM, which is faster than any other tool in the market today. So customers asked for smarter, tougher, faster. We've responded with smarter, tougher, faster. What it also is capable of doing, drilling automation and big data analytics. Automation and data analytics are big drivers in the industry today. This tool is capable of drilling automatically. We can utilize our drilling software, our automation software, and importing a customer's drilling plan. Tell the tool, I want you to drill to this plan. And this tool will take that data and drill automatically, basing its directional changes based on its current position and how close it is to that original plan. And we've successfully been able to land wells to the plan with no intervention from the drilling operator themselves. So drilling automation is a very, very important part of the industry today, and it's something Halliburton has been able to meet that challenge. We also tie our iCruise to our GTI bit, which is from our Halliburton drill bit service. We optimize each bit based on the characteristics of the iCruise. We use our Dotchi software to make sure we're designing our bit with the side cutter efficiency to match the drilling capabilities of the iCruise, so we're able to ensure that we're not only landing the well correctly, we're actually drilling the hole the best possible way and making a hole that is in a uniform shape and size, so we're able to get in the hole and out of the hole cleanly and able to get casing in the hole and improve our cementing jobs as well. So whatever happens here is very has a large effect on the overall remaining completion of the wellbore. So by utilising the iCruise and the GTI bit, we are drilling the best possible well to ensure we get maximum recovery for our customers.
If I could ask you a quick question, you talked about drilling automation. How does that integrate with the rig on location? Is that something that you can go to almost any drilling company and try to integrate that into the rig? Or?
Yes, in any drilling company, any rig we operate with, we're able to utilize the drilling automation software and drill to plan. We will obviously, if required, we can either have drillers on location or we can have drillers in a remote operating center monitoring and making sure that the tool is operating within the correct parameters and going in the right direction. Okay. Very simple.
And can you also describe the difference between point the bit and push the bit?
Okay, so now this is a push the bit system, and like I said, you have these pads all around the tool. The pad will come out, push against the formation, and that force will send the bit in the opposite direction. And this pad will open and close, open and close, open and close, depending on the rotation of the tool, depending on how much directional change is required, whether it's 1, 2, 3, 4 degrees per 100, all the way up to, we've successfully drilled 15 degrees per 100. Wow. So that is a push the bit system. A point the bit system utilizes an internal cam mechanism that actually will push inside the actual tool, and it has the effect of pointing the bit, so the bit will go in the direction that you want it to go. So the point the bit system is all internal, whereas a push the bit is all external. We've found, and most companies have found it in the shale plays, where you're required to build very high angle curves very quickly to maximize the amount of lateral placement in your lease, in your reservoir. The push the bit system seemed to give a much better drilling capability.
Thank you. And what fires these to come out?
We have our check valves in here, and we have the microprocessors in the actual tool itself, obviously going from a digital signal to a mechanical signal, and the fluid running through is what actually hydraulically pushes these pistons out. And when the piston comes out, kicks it off, and when it closes up, it also traps fluid in here. So we have a series of check valves that allows that fluid to come out the backside, so we don't have pads hanging out.
And just to reiterate, a key difference between Halliburton's design here of the push the bit rotary steerable system compared to other competitors, that a lot of the other competitors' sleeves, this area here actually rotates slowly instead of full rotation speed with the rest of the downhole tool, right?
Yep, correct.
All right, so thanks again, Des, for doing another video blog with us.
Anytime.
Thank you.
I really appreciate you guys having us down here at the exhibition. It's the second year running. Looks like it's going to be a great success again, and look forward to next year.
All right, thanks, Des.
Thanks, mate.